Good morning all. Today we'll start with the JEE Mains 2016 offline question based on combination of capacitors. So in this problem, combination of capacitors is shown in the figure. You can see in the figure. The magnitude of electric field. You want to calculate electric field. Let me take this nothing but a positive charge. Means charge at a distance r. At a distance r, we want electric field. The electric field can be written as kq divided by r square. So already r is given here at what a distance? R equal to 30 meters. K, of course, we know K is equals to 9 into 10 to the power of 9 Newton meter square per Coulomb square. Right? But what we require to calculate this charge is a sum of the charges of 4 microfarad and 9 microfarad. 9 microfarad. So this, if I take it as this is Q1, that's nothing but a Q2. So Q should be Q1 plus Q2. So we have to calculate the charges on 4 microfarad and 9 microfarad. How to calculate this one? Right, many methods are there, but I'm introducing a method. Okay, in a IIT level, we'll use that method. Okay, so that is called a nodal method. Nodal analysis will be called. Nodal analysis. So what is this nodal analysis? Right, this nodal analysis is nothing but first to identify the nodes. So what is nodes? Nodes means these are the points 1, 2. So let me draw here. First identify the nodes 1, 2, 3, 4, 5, right? 6. Like this, we have to identify, right? Now, next after that, if I see, first nodes are identified. Now here, when the battery is there, you take it as a plus 8 volts and a 0 volts. So here 8 volts will be there, here 0 volts across this ends. One end is 8 and 0. This 0 can be transferred till here 0. Here it is 0. Here one more point, if I take it is 0. Next here 8 volts, 8 volts. Here also 8 volts. So these are what's the potentials across each points 1, 2, 3, 4. So what we don't know here. Okay, first we have to analyze where the potential we have to, unknown potential we have to detect first. Number one is unknown potential. Unknown potential V. So here unknown potential is here, right? This node we are not able to know. If I know this one, we can calculate the charges at that particular point. So if I want to calculate at X, now how to proceed with this nodal analysis? First we identified unknown potential, which is nothing but X. Let me take it as X is the unknown potential. Now I'll draw that circuit 1. Here it is X, which is connected to here it is 0, right? Now here it is X. Here 8 volts. Let me take 8 volts is there. Here 8 volts. Here it is nothing but X. Here it is nothing but 0. Here also this can be transferred here X. Here X volts. Here also X volts. And it is 0. This is also 0. Here also 0. Hope this is clear, right? Anybody? Any doubts here? This is 4 microfarads. This will be 3 microfarads. Here 9 microfarads. So according to the nodal analysis, so nodal method, right? The sum of the charges, the net charges should be 0. That is Q1 plus Q2 plus Q3 is equal to 0. Conservation of charge. We can also call conservation of charge. So let me take it as charge on this one is Q1 between Q2. Here it is nothing but Q3. Hope this is clear. So Q1 is charge on 4 microfarad, Q2 is charge on 3 microfarad, Q3 is charge on 9 microfarads. Is it clear? Now the total should be equal to 0. What do you have to do now? Q1 plus Q2, Q1 plus Q2 plus Q3 should be equal to 0. There's nothing but net sigma is equal to 0. Is it clear? We know that C is equals to Q by V, or Q is equals to Q equal to C into V. This is what Q equal to CV. So I can write now here, instead of Q1, C1 into delta V plus C2 into delta V plus C3 into delta V equal to 0. Hope this is clear till this point. So anybody, any doubts, let me know, then we'll proceed. Now see here. Yes, C1. What is C1? C1 is nothing but 4 into delta V. Delta V means potential difference across 4 microfarads. What is the potential difference across 4 microfarad is x minus 8, like this. Plus now C2. What is C2? C2 is nothing but 3 microfarads. So 3 into potential difference across it, x minus 0, or x, simply it is nothing but x. So we can write it as 3x plus C3 again 9. Fine. 9 potential difference x and 0 it is there, which is nothing but x. So 9x is equal to 0. Hope this is clear to all. Next we can proceed at this particular point. 4x minus, that is 4 8s, okay, 32. Next plus, here we can take 3x plus 9x, which is nothing but 12x is equals to 0, or simply we can write 16x minus 32 equal to 0, or x equals to 32 by 16, which is nothing but 2 volts. So what we got here, 2 volts, right? This is clear. 32, x equals to 2 volts. Fine. So x is equal to 2 volts. Now you can substitute here 2 volts. And substitute here 2 volts. That's all over. Now we can calculate the charge Q1. You can calculate how to calculate Q1 charge. Q1 we know potential difference and 4 microfarads. Now let me calculate C1 here. How to calculate? So C is equals to Q by V, or a delta V, or simply I want a Q1 equal to C1 into delta V. Now Q1 equal to C1. C1 is how much here? 4 it is given. 4 into delta V. Delta V means 8 minus 2, which is nothing but 6. So difference of it is nothing but 6. So C1 into 4 into 6. Hope this is clear. 4 into 6 means 24 microcoulombs. 24 microcoulombs. That means the charge across this 4 microfarads is given as 24 microcoulombs. We got. Next, if I want Q2 or Q3, here we want Q3. Why? Because here let me take this is a Q3. No, Q3. We want only charges due to what and what? 4 microfarad and 9 microfarad. Even we can calculate 3 microfarad also, no problem. Right? Now coming back to here, Q1 is equal to 4 into 6, which is equals to 24 microcoulombs. Next, Q2 or Q3. Let me take it as Q3 equals to, so C3 into delta V. Now C3 is nothing but here 9 microfarads. So 9 into delta V. Delta V, if you observe, you can see this is 2 volts, x is 2 volts. So this will be 2 volts. This is 0. Here also 2 volts. It is 0. So difference in that it is nothing but 2 again. So that means 9 into 2. Hope this is clear. Which is nothing but 18 microcoulombs. Now total charge present on it. So total charge Q is equals to, total charge is how much? Now on this one, 4 microfarads we got 24 microcoulombs Q1. On 9 microfarads we got 18 microcoulombs. Add both the things. If you add, then we'll be getting a total charge will be 42 microcoulombs. Hope this is clear. So 1 Q1, here it is nothing but a Q2, 42 microcoulombs. Now 42 microcoulombs at a distance of 30 meters, we want to calculate electric field intensity at that particular point. Now you can substitute and finally get the answer. Here E is equals to, otherwise here only we'll do. So E equal to K. K is nothing but 9 into 10 to the power of 9 into Q. Q is 42 microcoulombs. 42 into 10 to the power of minus 6 divided by r square. R square means 30 whole square. So 30 whole square. Is it clear, that one? So will be, if you solve this one, so E at a particular point will get a 420 Newton per Coulomb square, right? So this is the final answer for this particular question, which is asked in JEE Mains 2016. Hope this is clear to all, how we can apply nodal analysis. Yes, is it clear? Fine. So try to understand the problem here, which is given in JEE Mains 2016, 9th April online. So according to this question, 3 capacitors are there with us. 3 capacitors, each of 4 microfarads. Let me take 3 capacitors. First one, the second one, 2, 3, and 4 are there with me. So each of it is how much? Each of it 4 microfarads, 4 microfarads, 4 microfarads, and 4 microfarads, right? Each of it is what? 4, 4, 4, and 4 microfarads are connected in such a way that effective capacitance we should get 6 microfarads. So first thing, to get a 6 microfarad, these 4 capacitors, how we have to connect? Let us take all are in series. Option wise, when we go, all are in series. Let us go with all are in series. If I take first one, series, all are in series. What is the formula for series? Now let me take it as C1, C2, C3, C4, all are equal to C. I'll take C, 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 and C. Can you tell me what is series? What is the formula for series? Anybody? Parallel means C1 plus C2 plus C3. Fine. Sorry, only 3 capacitors are given here. So, sorry, 3 capacitors are given. Right. So, C1, C2, C3. Right. 4, 4, and 4 microfarad. Series. Series means 1 by C. 1 by C is equals to 1 by C1 plus, that is in series if I take 1 by C plus 1 by C. Right. So, 1 by C as series is equals to, so this I can write a 3 by C, or CS is equal to C by 3, or CS is equal to C by 3. C by 3 means 4 divided by 3 microfarads, which is not possible because we want effective is 6 microfarads. So this option all series is wrong. All parallel will take parallel combination. If I take all are in parallel, I can write a C in parallel equal to C1 plus C2 plus C3, right? So 4 plus 4 plus 4, how much it is? 12 microfarads. This is also not possible. Now let us go with the 2 in parallel, 1 in series, 2 in a parallel, third case, 2 in a parallel and 1 in series, 2 in parallel and 1 in series. So here it is 4 microfarads, 4 microfarads and 4 microfarads, right? 2 are in parallel, 4 and 4 are in parallel. So when they are in parallel, it can be modified circuits. So these two combination, 4 and 4 combination will give 8 microfarads and 4 microfarads. So again, I'm getting these two are in parallel to each other. Series means C1, C2. C effective if I want. C1, C2. 8 into 4 divided by 8 plus 4 is 12. This is 1, this will be 3. Now C effective I'm getting here. C effective is 8 by 3. Hope this is clear. So this is also not possible. So what is the last one? It is possible. Let us see. 2 are in series. D option. 2 are in series. 1 is in parallel. So let me take 2 are in series. 1, 2 are in series. And to that 1 is in a parallel. Let me take this combination. So here are 4 microfarads. Here are 4 microfarads. Both are in series, right? And this is in parallel to it. When both are in series, so C in series is equal to C1 C2 by C1 plus C2, or we can write 4 into 4, 4 into 4 divided by 4 plus 4 is 8. This is 1 2 here it is nothing but 2. If I modify the circuits, I'll be getting like this. So one is 2 microfarads, is nothing but 4 microfarads. Now total effective capacitance is nothing but C1 plus C2, which is nothing but 2 plus 4 is 6 microfarads. Fine. It's nothing but 6 microfarads. Is it clear this one? 6 microfarads. So which correct option is D. Hope this is clear. Anybody Any doubts, let me know. I will proceed. C effective for C option, we got this one. And first case series, second case parallel, all are in parallel. So D will be the correct answer. C is wrong answer. Hope this is clear to all. Everybody, any doubts, let me know. So now we'll move to 2016 mains 2016 question, 10th April online. There are a number of capacitors are there. We can see for figure shows that network of capacitors where the number indicates the capacitance in microfarads. So your number is indicating each is in microfarad. The value of capacitance C, if the equivalent capacitance between point A and B is 1. That means the effective C across AB is given as 1 microfarads. That's number 1, right? Now let me take here first these two are in series or parallel. Can anybody tell? These two are in series or parallel. 6 and 12 are in series or parallel. Series. Can you tell me what is the effective will gets for that one? 6 into 12 divided by 6 plus 12, right? So which will get 18. How much you get? Can you tell me? 4 microfarads. Yeah, very good. Somebody posted their answer 4 microfarads. So that means here this combination is 4 microfarads. Okay. Now coming back to 2 and 2 are in parallel to each other. When they are parallel to each other, this will be getting how much? 4 microfarads. So this is nothing but 4 microfarads. Is it clear? Now we'll modify this circuit here. Let me draw. This is nothing but 1, 2, right? Here fine. So this is the circuit now. Let us write the values here. So first one is C as it is. This is nothing but A and B across. So 1 microfarads. Here we are getting a 4 microfarads. 4 is there, and one more is attached here. Already we got effective. Fine. So we got here 4 microfarads. This is nothing but 8. This is nothing but 4. Hope this is clear, right? Now again, this 4 and 4, how they are? Can you tell me? Now these two, 4 and 4. So this 4 and 4, how they are? In series or parallel? Series or parallel? Parallel to each other. Now can you tell me parallel how much it will become? How much? Series and parallel, how much it is? Now these two are in again these two, 8 and 4. They are in series. When they are in series, yeah, parallel. 4 and 4 are in parallel. Answer is 8. So this complete will becomes now 8 microfarads. Now 8 and 4 are in they are in series. Can you tell me what is effective there? Effective how much you'll get? They're in series. 8 into 4 by 8 plus 4, right? So here I'll get 8 into 4 divided by 8 plus 4. So 8 into 4 divided by 8 plus 32 divided by 12, which is nothing but 8 by 3 microfarads. So I can write this is 8 by 3 microfarads, right? Now again we have to reconstruct this one. Fine. Now here 8 and this is 8 and 1 are in a series. So let me reconstruct this diagram again. Here I'll reconstruct. Let me take here a C as it is. C is there. Then 1. Fine. 8. Here it is 8. Yeah, 8 and from this points. Fine. So we got 1 is 8 by 3 here. Let me write 8 divided by 3. 8 divided by 3 microfarads. Here 1 microfarad. Here 8 microfarad. There is nothing but C capacitance A and B. Right. Next one more. That's all. No? 8. Fine. Now 1 and 8 again in series. So what is this combination? Can you tell me? This combination they are in series to each other. Series means 1 into 8. So 1 into 8 divided by 9, which is 8 by 9. Fine. microfarads. Now final circuit I'll draw here 1. So like this we have to find. So here it is nothing but a C. This is C. It's nothing but A. Here 8/9 microfarads. Here it is 8/3 microfarads. Now these two are in parallel to each other. Fine. When they are in parallel to each other, simply you can add that one. Now final I'm writing here. When I add both the things, what I'll get 8/3 plus, otherwise directly we'll take it as this is nothing but a B. Here I'll once again write. So there's nothing but C. Here A and B. Fine. There's nothing but C. Here it is 8/9, 8/3. Fine. Now if I construct that is 8/9 plus 8/3, they are in a series. We can write 32 divided by 9 microfarads. Now final we'll get here. Finally, one more I'll draw. So 1, so next 2. That's all. So A and B. One is 1 microfarads. Sorry, this is nothing but C microfarad is a C. That's all. No? Yeah, C and 32/9. 32/9 across this effective capacitance. So CAB, these two are again in a series or parallel. They are in series, right? Across this one is given as a C effective. As they are in series, CS is equals to 1 by C plus 1 by 32/9 or 1 by CS. 1 by CS means already given. Here across AB is 1 microfarad. So 1 by 1 is equals to 1 by C equals to, it will goes up, plus 9/32, 9/32, which is nothing but 1 by C equals to 1 minus 9/32, or 1 by C is equal to 32 minus 9, which is nothing but 23 divided by 32, or simply I'll get C is equals to 32 divided by 23 microfarads. Hope this is clear, right? Fine, this is the way that when we are doing, just try to modify fast. See, by seeing itself, calculation can be done in your mind, and final result you can write. So I'm showing this is the basic way that you have to solve for starting or initial levels, right? Hope this is clear. If you have any doubts, let me know here. Anybody, any doubts? Sierra JEE means 2018, 15th April morning online question. Equivalent capacitance between A and B. We want to calculate between A and B. So I'll modify the circuits. Let us see. First one is 6 microfarads. 6 microfarads. And here are 2 microfarads. I'll keep it like this. 2 microfarads. Next here one more here, right? Fine. So 5 microfarad and 5 microfarad. Let me show you. And next here 4 microfarads, and here it is nothing but parallel to its 2 microfarads. So across A and B, across A and B. If I take here 6 microfarads, next here it is 2 microfarads, here it is 5 microfarads, and here it is 5 microfarads. Hope this is clear. Next 4 microfarads, 2 microfarads. Now you can try this one. First make it complicated in a simplified manner. Identify which is series, which is parallel, and reconstruct the circuits so that it will become easy now. Come and try the problem and tell me the answer. Now here are 2 microfarad, 5 microfarad, and 5. These are all in parallel. In the parallel, I can write here this combination, this complete combination will get 5 plus 5 plus 2 is nothing but 12 microfarads. And this combination is 6 microfarads. Now you can reconstruct this circuits. Reconstruct 1, 2, 3. That's all over A and B. Reconstruct here. So we'll get 6 microfarads, 12 microfarads, and 6 microfarads. Now, if I want to calculate the effective 1 by C across AB equals to 1 by 6 plus 1 by 12 plus 1 by 6, which I'll get 5 by 12, 5 divided by 12. Now, C 1 by C AB equals to 5 by 12, 5 divided by 12, or C AB equals to 12 by 5. It's nothing but across AB, that is the effective capacitance across AB is 2.4 microfarads. Hope this is clear to all. So this is the way that you can calculate. Yes, all of you done. So simplifying, hope this is clear. Now if you take 1, 2, 3 are in parallel to each other, and these two are in parallel to each other. These three combinations, so 1, 1, 2 and 3 combinations are in a series. Hope this is clear, right? 1, 2, 3 are in a series, and these two are. Okay, all of you. Hope this is clear to all. If you have any doubt, let me know. Then we'll move with the next question. So try to calculate 2017, 8th, April 8th. Let's try this question. Let us see. So here 2017, 8th April online question to calculate. Let me do here. The energy stored in an electric field produced by metal sphere of 4.5 joules. So energy, let me take energy U equal to 4.5 joules. 4.5 joules. The sphere contains, so sphere containing a charge Q is equals to 4 microcoulombs of charge. So its radius. That means if I take a sphere, it's nothing but a sphere. Sphere contains some charge. So sphere has some charge. We want to calculate radius. So charge is already given. There's nothing but charge on this particular sphere. Hope this is clear. It's nothing but a sphere is there. On the sphere, we want to calculate radius of that one. Radius. How to calculate a radius? Let us see. So U is equals to energy stored. I can write a Q square divided by a 2C. It's nothing but a spherical capacitance. C is equals to 4 pi epsilon naught into R. So let me take it's an equation number 1. Equation number 1, energy stored in the capacitor and capacitance of a spherical capacitor. Now substituting equation 2 in 1. 2 in 1. That means U is equals to a Q square divided by 2 into C. There's nothing but 8 pi epsilon naught into R. Otherwise, you can make it as 2 into 4 only. Fine. Now, I can write U is equals to, let here, U equal to Q square, K Q square, K Q square divided by, because 1 by 4 pi epsilon naught I am writing here, this can be written as now 1 by 4 pi epsilon naught into Q square divided by 2R, right? So 1 by 4 pi epsilon naught completely, I am writing it as K Q square divided by 2R. Hope this is clear. Now what we require, R equals to K Q square divided by 2U, radius required to calculate. So radius K, already we know that value of it, simply substituting the value. If I substitute the values here, R equal to radius, R equals to 9 into 10 to the power of 9 into Q square. Q square 4 into 10 to the power of minus micro, 10 to the power of minus 6, right? So minus 6 whole square, that is 4 into 10 to the power of minus 6 whole square divided by 2 into U. U energy given 4.5. I hope this is clear. Now how much you can expect the answer here? 16. So 16 into 10 to the power of minus 3 meters, which is nothing but 16 millimeters. Am I right? 16 millimeters. Now radius, the sphere R equal to 16 millimeters. Right? Hope this is clear. Fine. Any doubts? So answer matches with the option D, which is asked in 2017 April 8th. Great. Now this problem you try. Now 3 minutes is there. Otherwise, as a homework, it's nothing but for homework. You can try. Just note it down. This, take a screenshots, make it as homework. Fine, all of you. Hope it is clear what we discussed today. JEE. Today we started discussing from 2016, right? Started discussing about this previous IIT-JEE questions. 2016 we discussed, and in that one important we discussed nodal analysis. Then after 2016 capacitor combination, 2016 9th April online. Then we discuss again combination of capacitors. After that, given one homework to you. Then energy stored based on energy stored and a spherical capacitor. And again equivalent capacitors, which is asked in 2018. Right? Hope this is clear till this point. But if you have any doubts, let me know. Hope it is clear. Thank you.